So Jiva, in the last few segments we've been looking at some really cool features of Objective-C, as we've said, the objective part of Objective-C. But we're going to move back to something now that is probably more from the C side of Objective-C in macros.
Right, so when we talk about macros, we're actually talking about preprocessor directives. When we talked earlier about the preprocessor, there's actually commands that you can use to essentially talk to the preprocessor and have it manipulate your code while it's compiling it. So it gives you the capability to actually make changes to your code programmatically as part of the compilation process. In fact, the word macro actually comes from this idea of taking something small and expanding it up into something bigger. So if you think about one of the preprocessor macros that we've already seen, that is the pound import preprocessor macro, what that preprocessor macro actually does is it goes out and it reads a file off of disk, it pulls it in, and it replaces that little pound import line with all of the code that is in that include file. So that's really where the whole macro idea comes from. And it's really a very powerful concept, or very, very powerful programming construct. And so let's take a look at a couple of examples here. So here's an example where, again, we've got this pound import in there. We've already seen this. But now we've also got this other preprocessor directive called pound define. And pound define allows you to essentially say, everywhere in my code where you see the following word, in this case it's stuff, I want you to replace it with dead beef. And it's actually going to be this whole thing here, the @ dead beef, close quote. Mm-hmm. So it's always going to look like this, in that you've got pound define, then you've got the word to replace, and then whatever you want to replace it with. So now if we look at this code down here, we actually see that down here we have this nslog where we're actually logging the word stuff. And stuff is actually here going to be replaced with the word dead beef. So if we then go and take a look at so to give you an idea of exactly what will happen when the code is actually compiled, when it goes through the preprocessor macro stage of things, it'll actually basically do exactly this. It's going to take out that pound define, and where that stuff was, it's going to actually put the word @ dead beef, close quote in there. So if we run that code, actually we'll see that it's done exactly that right here. It's actually printing out the dead beef just like we expected it to do. So that's kind of an example of a very simple preprocessor macro. Pound define is really powerful. It lets you do all kinds of interesting things. For example, another example that is often used is in cases where you have certain special keywords that you want to use as keys. For example, in this particular code, we're actually accessing objects out of a dictionary. And of course, we'll be talking about dictionaries when we talk about the Foundation framework. But the idea is that this dictionary has objects associated with keys, and those keys can be strings and those kinds of things, right? And so in this case, we have this object that's associated with the key my big key name. Now, the problem is that if you use just quoted strings like this, you're going to wind up fat fingering it, making mistakes and things like that. And the compiler, of course, or the Xcode code completion doesn't do code completion on the strings themselves. So you really want to replace these maybe with constant symbols, something that the code completion will complete for you. So this is actually a great place to use a pound define instead. You can prevent errors because the code completion will finish a lot of it for you. But also, when you go to compile your code, it'll actually check to verify that what you typed is actually a valid symbol. And so if we look at an example of where we've actually done exactly that, here we've defined my big key name as that string, right? And then when we go to set the object on that, we just use that macro right there, and it'll just replace the defined macro with the actual string.
I notice all these defines that you're creating so far, you're putting them all in uppercase. Is that just a sort of good practice? It's not required, it's just good practice.
It is not required. It's just good practice. Now, typically, you bring up a good point. Not only is it in uppercase, but I've also separated all of the words in my names with underbars. That's another standard because you can't have any spaces in the names. Once you have a space, it assumes that you're on to actually defining what will actually be part of the macro. So you can't have a space in the name. So instead, just as a general standard, people like to use underbars in places of names. So let's take a look at some more examples here. Here's another example where we're defining this debug symbol, right? We're saying debug 1. We're just defining it to be that. Now, there's also some nice other preprocessor directives that enable us to check to see if something has been defined at all or not. So, for example, in this particular case, we're saying define debug, and then if debug has been defined, then we will actually define this debug log macro. Now, there's a couple of different things going on here that we're gonna look at, but the important point that I want to go through first is that it's checking to see if debug has been set, and if it has, then we get this version of debug log, which prints out an NSLog message. But if it hasn't been defined, then we actually define debug log to be nothing, because it's just debug log such and such, and there's nothing after it. It's just empty. So in other words, when we come down here and we're actually using this debug log macro, then what will actually happen is it will, if we're running in debug mode, it prints out our debug message. If we're not, it doesn't.
Simply because actually debug log there will be replaced with the NSLog call.
Correct.
By the preprocessor. It will be replaced by nothing if it's not defined. Therefore, it's just a hanging string that will just disappear.
Just does nothing. Exactly. Now, this is really powerful, just this one little thing here, because this enables you to, by setting different defines, by doing this pound define, in this particular case it's doing debug 1, you can have different code compile into your application based on these settings. And the really cool part about this, in this particular case, right, I'm just doing it right here at the top of my file. So, there's not really much to that, right? But the really cool part is I can actually take this out and I can go in here into my build settings and I can look up preprocessor macros right here. And I can actually configure a define right here as part of my build target settings to define or undefine things like that debug macro. So if I did that, then what would actually happen is, for example, I could have two targets, one that's my debug target and one that's not my debug target. And just based off of switching my target settings, I can have my code compile in different ways.
Right, okay.
One of the ways that I do this on products that I ship is, for example, I have a light version of my product and I have a full version of my product. And when I ship the light version, I have a light preprocessor define that I set, and when I have the full version, I have the full preprocessor define that I set. And that enables or disables certain features. Make sense?
Yes.
So if I wanted to, just as an example, if I were to add a preprocessor macro here, if I wanted to do what I was doing there, then I could just say debug equals 1 there, and then that would effectively set that preprocessor macro right there.
So it's going to effectively create the @define in every file for us.
Yes.
Okay.
So that kind of gives you an idea of sort of the power of what you get out of these preprocessor macros. So let's look at a few other examples here. Here's another example where this is getting a little bit more complicated. In this case, we're actually making a pound define here, defining another macro. And in this case, the function is logline. And what it'll actually do is it's using some built-in preprocessor macros, the underbar file preprocessor macro and the underbar line preprocessor macro. Now these are actually built into GCC. And what these will actually do is they will replace inside your file the location and file name of the file that's being compiled.
Right, okay.
So in other words, by doing this little log line thing, right, down here where we actually use this macro, if we were to actually run this code, it would actually output the line and file name of that particular file. Same thing here where we're doing this nslog and we've got these two strings here and we're outputting the date and the time that the file was actually compiled.
So those ones there, they're not even in a defined statements because they're predefined.
Right.
And so they're fixed preprocessor symbols which are going to get replaced.
Right, exactly. Those are provided to us by GCC. Mm-hmm. So really cool stuff. There's a whole bunch of these kinds of variables that are in GCC. I recommend just looking at the GCC documentation. I mean, we could probably do a whole class just on the preprocessor and manipulating things and programming it and things like that. So, we've still got some more to go. But the point is, I mean, if you really wanted to delve into some of these, one of my favorites is there's one called underbar pretty function underbar. And what that does actually is it prints out the name of the method name or function that you're in. So I like to use that, for example, for debug logging and stuff like that. I'll just stick in these macros in there, and that way I can watch in my output on my computer as I'm entering and exiting methods and things like that. It's pretty cool.
Oh, cool.
So let's look at a couple more examples. So like I said, we've looked at, we can define anything to be anything, basically. You could even do like pound define private to public and things like that if you wanted to mess around with your C++ programmer friends. You can also do, very long strings. So for example, if you had pound define bar, and then you wanted to have a long string that stretched over multiple lines like this one that says, this is a very long string which just keeps yammering on and on and on, and so on and so forth. Now, in order to do that, you have to do standard line breaking rules with that, which means that you end each line with a backslash, and what that tells the compiler is, hey, this line is continued on the next line. So when it goes through the preprocessor, it'll actually take each one of those lines with the backslash, and it'll just pull it up and make it all into one line.
You'll just get one line, yeah.
Right. You can even define macros based on other macros. So in other words, like for example, we had this bar macro that we just defined. Because it's defined, I can now define another macro called baz, which will be exactly the same as bar, just by using that bar there. Now, of course, I mean, it depends on which one was defined first. I mean, if bar wasn't defined, then I wouldn't get anything. If I defined bar after baz, then I wouldn't get anything. But that gives you an idea that you can kind of reuse these things as well. There's also, you can also use parameters. So you can actually kind of write little functions in these macros as well. So for example, this first macro here, we are defining a max function. It's just a quick little function that takes an x and a y parameter, and it will return the greater of the two of those, okay? And so it basically just says max. To do this, you do max, and then you have an argument list in parameters, or in parentheses. Now, in this particular case, when you're doing macros, you don't have data types. There's no data types associated with these values. You're just going to get in essentially hard-coded numbers. That's what's going to happen. They're just going to come right in, whatever they are. And so you've got this x and this y, there's no data type associated with them. Now, in order to use those parameters, of course, then you can actually just use them right over here in your macro body. Again, we're doing this just like when we talked about the ternary operator, right? We're using a ternary operator here to say if x is greater than y, then return x, otherwise return y, basically. Now, there's a little subtlety here. You may have noticed looking at this, there's a lot of parentheses in there. And the reason that we're doing that is because, remember I said, you're just going to get whatever number is passed in. Well, it's entirely possible that the number that's passed in there might actually be an expression. So it might be, say, for example, 5 plus 5. Is 5 plus 5, you might do something like, let me show you an example. Like you might do max 5 plus 5, comma 6, something like that, right? And so you want it to actually make sure that it completes, or that it executes whatever that expression is and arrives at an end result before it actually does the evaluation.
So
that's why
the parentheses are forcing the operation order on things.
Right, exactly. There's another neat feature of macros called stringification. And what stringification does is, for those arguments that have been passed in, it'll actually turn them into strings. So, for example, in this code here, we have, we're logging this variable, log var, okay? And then we're outputting it using an NSLog, and we're doing this %s format string. But what we really do here is we have this extra pound in front of the reference to the passed parameter. And what that does is it stringifies the passed parameter. So in other words, if you do, for example, log var x plus 10, what it will actually print is x plus 10, rather than actually evaluating that expression.
Right, okay.
So that can be kind of a convenient way to make a macro that, for example, prints the value of a variable. Like you could say, you could reuse this macro and you could say, like, log out this variable, and you use the stringification for a label for that variable. So you say like log variable, and then it stringifies the name of the variable, prints out the name of the variable, and then like a colon, and then prints out the actual variable value.
Makes sense.
Pretty cool stuff. So there's all kinds of, like I said, all kinds of power in the preprocessor directives. Here's a list that is going of all the different preprocessor directives, or at least the most commonly used ones, and what they're for. So first of all, we've got pound define, which we just saw. That basically defines a new macro or constant. Mm-hmm. Then there's also pound ifdef, which begins an optional compilation block, and the compilation block will be compiled if whatever value is given after that is has been defined.
Yep.
Then there is pound undef, which allows you to essentially undefine something that's been defined.
Right. Okay. So that's expecting you to put something that you have defined somewhere else.
Right. Exactly.
Just ignore it if it hasn't been, or does it give you an error?
I think it just ignores it.
Okay. Yep.
Then there is pound import, which we saw, right? That imports a whole file, and that will check to see if it's already been imported. Of course, we talked about pound include, which was that C preprocessor directive, which will import a file and not check to see if it's actually already been imported. Then there's kind of a neat one here, this pound pragma, which is actually a special compiler and IDE command. Now, there's several of these pound pragma macros that are available in Objective-C, but probably the one that you'll see most often is the pound pragma mark preprocessor macro, which is used a lot in Objective-C code because it enables you to tell the Xcode IDE some kind of a label to show in the dropdown for your source files. I'll show you a quick example just for the sake of doing it. So, for example, if I wanted to add a pound pragma mark, all caps, should be all lowercase, pragma mark foo right here, right? And then I save that, and then I pull down this little guy right here. Notice I now have this foo label inside of the IDE.
Well, okay.
Another really cool part is you can also it's got a special one for pound pragma mark hyphen, which should give you a horizontal bar. You see that right there?
Right, okay, yep.
So this is really cool because you can use it to mark sections of your source code. And then when you're in Xcode, you pull down this drop down and you can have like all these little comments in there that tell you, these are my, for example, UI table delegate methods, or these are my, such and such methods, and things like my initialization methods and stuff like that. Cool stuff. So going back to our table here, we also have pound warning. which will actually just generate a warning right in the middle of your code. Now, this can be convenient, in particular if you've, for example, you've probably, I know I have, all the time I'll put in a comment, / fix me, : and then some kind of note to myself, right? Well, you can also use a pound warning to essentially kind of alert you every time you build your application. Hey, there's something here that needs to be fixed, so you can't forget, right? It's sometimes I'll put in those fix me's and then I'll forget, and 6 months later I'll be in there working on my code and I'll go, oh look, there's this fix me that I made a note about that I was supposed to fix and I never did. Same thing with the pound error preprocessor macro. That will actually generate a compiler error wherever you put it.
Right.
So you can just say pound error and then some message, and it will stop your compilation and print out that error message right there.
Okay.
Finally, we saw the if-def and the if-def statement earlier with an optional compilation block. You can also use pound if and pass it something to evaluate, and if that evaluates to true, then it'll compile the code that follows. If not, then it will. Then it won't. There's also pound else, which works like an else with the pound if and pound if def preprocessor macros. Same thing with pound elif, ELIF, which is used in a similar way to like an else if statement.
Right. Okay. Yep.
And then finally, whenever you do a pound if or a pound if def, you always need to terminate it with a pound end if at the end of that optional compilation block, so that you make sure that you are delineating what's going to be compiled and what's not going to be compiled. So that's pretty much the gist of macros, and it's a powerful thing. It's cool because if you think about it, it lets you manipulate your code while it's being compiled, which is pretty neat. It's like a compile time language for your code itself.
I mean, two immediate things that come out there that are just huge is that ability to define your strings as constants and reduce errors without having to declare consts in your code as such, and equally that ability to effectively create two code bases out of, or three code bases or four code bases out of one code base, by using the if and if defs systems in there. Plus all the other stuff that's just generally useful. Yeah,
very cool stuff.
So, macros. That's good. What will we be doing next?
Handling errors.
Oh, we're not going to get any of those,
are we? We don't write errors, but
occasionally, for those who might get some errors.
It's for defensive programming against your coworkers.
Okay. When we come back, handling errors created by your coworkers.
Bye.